later. I'm going to do a new share now, and the new share is going to be the Google Chrome. Okay, can y'all see my blackboard? Okay, I'm going to click on this is my course list. Here's a Math 112, that's us. So I'm clicking on that. Okay, and then under, there's our announcement today. Okay, click on the weekly assignments, but weekly assignments, you have to hit the down arrow over here on the right hand side to get it to open. So you do that. Now, you were asking about the YouTube link, weren't you? Say again? Okay, now say that again. Was it the YouTube link that you're looking for? Is that what? Okay. Okay. Let me do YouTube first since we're here. So I'm going to open week 1. You could either click on week 1. I'm over here at the down arrow, so I'll open there. Okay. And week 1's over, but the instructional materials listed in week 1 are good for the whole term. Okay. So I'm going to click on that, instructional materials, blah, blah, blah. And it says here, I'm going to have to move this out of the way. Okay, it probably wasn't your way. You see recorded lectures, and this is the link to the YouTube. And over here you'll see the word list. That's the playlist for this course. Okay, did you look here? Okay, that's where it is. You want me to open it and show you how to get to it? Okay, all right, so there that is. Okay, now, you also set assignments. So let me just go to week 6, which is the week we're in now then, okay? So I'm going to get out of this one and go to week 6. I'll close week 1 and go to week 6. Okay, opening week 6. Oops, opening and then closed. There, okay. Now, there is all of week 6. Now, first in the overview and weekly to-do list, if you click on that, and this will be true for every week, past weeks, all the weeks, okay? It tells you what we're doing, when we meet, all that kind of stuff. It tells you the assignments down here, weekly to-do list, work some of the odd number exercises in these sections, and then here number 4, submit at least one homework exercise, especially any for which you're having difficulties getting the correct answers. So that's where you'll find the assignments for every week, just like this, okay? So that's the overview and weekly to-do list for every week. We'll have those assignments in them. Okay, now this week 6 discussion, no one's used it yet. I usually, after the week's over with, if no one's used it, I take it out. Week 6 homework. Okay, now sometimes it shows up here and sometimes it doesn't. I'll show you why. I'm going to open this one. I'm going to try to open this one. There it goes. Okay. All right, and here's the assignment. Please submit at least one homework exercise, especially any for which you're having difficulty getting the correct answer. Just like you saw in the to-do list, okay? So it's there also, okay? So that's week 6 homework, okay? And every week we'll have that. Oh, here's 2 more people trying to get in. Let me get them in. Where is the list now? It's not showing up. Let me. Okay, let me answer that question after I get people in here. This is Ladarius coming in twice. You can only vote once, Ladarius. You should know that. No, okay, I'm just kidding. Okay, Ladarius is coming in now. Okay. All right. So we're now at 19 students. Let's see if I got them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19. I think I've got everybody. Okay. Now, okay, the question on the homework. Now, for those who just joined us, the question was, where is the let me remember what it was, the YouTube videos. Okay, I've gone over that, but I'll go back over it in just a second. And also, where are the assignments? Okay, and as I just mentioned, you'll find them always in the weekly to-do list. They're always there. I meant to click on this one too, so hold on just a minute and let me click on this one, instructional materials. Even though the YouTube videos here, if you look here under recorded lectures, it says, please see the YouTube video playlist given in week 1. So that's why I started in week 1 rather than having to roll it in every week. I just say, go to week 1. It's there. It's the same playlist. And everything for the whole term is in there. Things we haven't done yet from past terms and things we've done, the ones we've done in this class are at the bottom. The things that were done in previous terms are at the top. So they're there, and every week you'll see this. Okay, so let me go back to, now the question was on the homework. Is that required or is it optional? Okay, I thought I explained this before, but let me make sure I get this clear. It's completely optional. It's completely up to you whether you do it or not. They require us to put it in here. If you turn in the homework, I'll show you in my grade book. I'll try not to show any names, but you'll see, I'll cover the names here, but you see I put pluses every time something has been turned in on the homework. It's not a score, and if you see it on the thing, the pluses are there. Okay, those pluses mean you submitted what was said to submit that week. Okay, if at the end of the term, okay, hold that thought and come back. The first thing you asked, you said, only if you need help. Yes, I want the homework. If you are having difficulty getting the answers, the correct answers, the answers are in the back of the book. They're at calcchat.com, and some of them are even at calcview.com. Okay, the check yourself or checkpoints that are at after every example, they're at larsonprecalculus.com, and you can do those. That can be your submission if you can't get the answers that are there, or if you just want to turn those in. Whatever you want to turn me in something. If you are having difficulty figuring out how they got that answer, even though you've looked at CalcChat, CalcView, larsonprecalculus.com, and you can't figure out what are they doing here, okay? Those especially I want you to turn in. That can be 5, 10, 2, 3, any number that you are having difficulty with, send me those. So I'll know that, and we can use those in class, because if you're having trouble with it, the odds are other people are too. They just haven't done the homework. Okay, so that's the thing. Now, if you aren't having trouble with the homework, then it's completely up to you whether you turn it in or not. But like I said, I do the pluses in the grade book. Also on the Blackboard grade book, it'll either have a 0 posted, that means you turned it in, or it'll have no grade if you didn't turn it in. And if you turn out with more posted, then you have no grades at the end of the term. Oops, here comes somebody else, I think. Oh, 2 more people. Let me get them in. Okay, Ivan's coming in, and Ladarius is trying to get in again. He came in twice before, and now he's trying to get in again. Okay, so Ivan is here. I can't get my pen to open. And I've already marked Ladarius. Okay, so now we're at 20 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 students. Excellent. Good attendance today, folks. Yes. That's perfectly fine. Yeah. And if you turn it in, that's fine. I check every week's homework every week. I check my Blackboard messages every week. I try to check um, emails every week. So however you turn it in, I'll try to pick them up. Now, sometimes I'll get behind on some because I get so many in a given week and I have so little time to do it, especially when the administration puts some huge task that we have to get done in 2 days or something like that, which they have done many times. But it's sort of eased off, knock on wood, a little bit now, so I'm trying to get caught up. But when I do have those, I will, when I get them, when I print them out, I'll usually send you an email, okay? Especially if it's on messages or an email. Now let me show you something else. I don't see any new people coming in, so let me minimize this. On this homework here, okay, I'm going to do week 6 again. No one, I don't think, has turned anything in here. Okay, yeah, it says 0 submissions. Okay, now if you send it in by Blackboard message or by email, it won't show up here. But notice when I click on that, I get the list of all the students, and if anyone had submitted it, then I'll click on that. You'll be underlined here, so I'll click on that, and then I'll be able to see your submission. And those, I won't usually send you a message back. I'll put your grade in right then. Okay, it'll be 0 out of 0, but I'll post it so you can see that I received it. So you won't get an email from me or a message from me if you send it through the week 6 homework, but if you send it through Blackboard message or an email, then when I see it and print it, then I'll send you the acknowledgement that I got it, and I put it in the grade book, and I'll put it on Blackboard when I can. That's what I always do. Okay, so let's get out of that then. And I want to show you this. Here's week 6 assessment. And the reason I'm going to show you this one is there's nothing there now. I'll show you. I'll pull it up. But probably later when you look at this, hopefully, I'm going to put the first test right here. You see where the plus is? When that plus is there, I can click on that and I can import your first test. And I think we'll get to that today, so I'll do that sometime this evening. Now, I don't have very much time this evening. I teach until 5:45, and we've got a pack to go out of town this weekend, so I'm going to really push it to get that there. But there will be your test. I'll also put it under Blackboard messages. Okay, so I'll go to that. And notice here, there's no due date, but try to get it in before I give you the next test. That's what I'll say. The grading is there, 100-point max, blah, blah, blah. So that's where you test. Now, it won't say week 6 assessment anymore. It'll say test 1. That's what it'll say. So when you see it change to test 1, you can check here and get it, or you can go to Blackboard messages and get it. Either one. All right. Yes. Do you have to use what? Okay, I still couldn't understand what word you said. My hearing's so bad. Oh, no, no, no. Oh, I know what you're talking about now. I don't do that, no. You just do your test, okay? If you're learning something, taking the test, then I think you're getting what you need out of it. So no, I don't go through that mess. It sounds like to me when I hear other people talk about it that it gives people so much trouble, and there's so many, it's just so convoluted and complicated. I just say, here's the test, do the test. To do the test, you're going to have to know the material, so do the test. Is that okay, or would you rather I use something like that? Okay. All right. Now, since we've been talking, so I'm going to close this out. Now, have I answered the question? There were probably 2 or 3 questions embedded here. Have I answered them all while we're here in Blackboard? Okay. Now, yeah, you got another one? Yes. Okay. Okay.
What chapter are we on?
We're in Chapter 1, Section 1.6. And we will.
Okay, so you want us to sit in 1.1 and so on
Okay.
for homework?
Okay, now 1.1 and 1 through 1.3 was basically review of Math 100 or 098 or high school math or whatever. So you can do any of that that you need review on. That's up to you. The homework I've assigned was in 1.4, 1.5, and 1.6. Today we'll have a few more in 1.7, hopefully, if we ever get there. So, but you can do anything you want to. The checkpoints that's legitimate. The exercises in the book, that's legitimate. And if some of you just absolutely love WebAssign, you can do them there and send those to me as well. So that's completely up to you. All right. Were there any other questions? All right. So I'm going to back out of week 6 here. Okay. And the next thing I'm going to do is just take you up, just in case you missed it earlier. Yuck, I went all the way out of the course. How did that happen? I don't know. This blackboard is so bizarre. Okay, here we go. Back in the course again. Back in the saddle again. Okay, when you go into the course, from most of the screens, not those individual weeks and stuff, you'll see here is the message icon. Okay, that, by the way, is the gradebook icon. Here's the message icon. I'm going to click on it now just to see. No messages there, but after class today, I will be putting your test here as well. Okay, Janae must have had to bump out and come back in because I'm pretty sure I already have her present.
Under week 6, correct?
Say that again.
You're putting the test under week 6, correct?
Okay, I'm putting it 2 places. Let me try to get Chance in here. Sorry that I have to interrupt here, but if I don't get them, I forget who came in. So Chance is here. Okay. Now, yes, the test I'll put in 2 places. One place will be here under Blackboard Messages, where the envelope is. The second place will be under Week 6, and what is now saying week 6 assessment, not assignment or homework or something like that, or discussion, week 6 assessment. I'll change that to read test 1. Okay, so you can get them either place. Week 6 week 6 under test 1 or here on messages. The thing is, especially if a student's been out, if they're looking for the test and have to go through every week to find it, that seems like it's a really awkward thing to do. So I put it under messages, so all you have to do is go to one place. But if you're doing homework and everything else through the weeks, then you'll see it there, so I put it there too. Now sometimes I may not be able to put something there, and remember when I showed you that little plus sign and I said now I can put it there? In this template, sometimes they left off the plus sign and I have no way to put it there. It's just this empty thing that I can't put anything there. You can send stuff to me, but I can't put it there. So anyway, that's just a quirk of whoever did these silly templates. Okay, can I go on and get out of Blackboard now? Any other questions while we're here? Okay. Okay. All right. Well, you're welcome to ask questions anytime. So let me go back to our PowerPoint, which is 1.6, which is where we were. And for those who may have come in late, there's been just a bunch of questions. And I've also had this. I had an email this morning. It's one reason I was a little late logging in. A student who said he couldn't get in Zoom on Tuesday. And I had something like 20 some odd students here, so I know it wasn't a Zoom function, but I do know that this week there have been internet problems. So, and some of you have been going in and out probably because you weren't getting good signals or whatever. I know one time I had to change my internet provider. We have a couple of different things here, and mine just went out in the middle of a class, or not, when I was grading or printing papers or something, and I had to go to go to a different one because my internet went out. So things have been unstable, it seems like, this week more than my wife said. At UAB the internet was having difficulty. If they're having trouble, I can believe anyone could be. So
Yeah, it was kind of hard for me to log on today. Like, you accepted me the first time, but you kept saying waiting, and it had like the little big circle on there. That's why I exited and like had to come try to re-enter.
right. And now part of that may have been my fault because, like I said, I was trying to answer that guy's email before class, and then so I was a couple minutes late myself, and a lot of people um, were out there, and I was trying to get them in as fast as possible. So it and you, I don't know if you can't see it, but they pile up at the beginning, and I'm doing everything I can trying to keep them in and also getting them in the roll book. So it's it's not easy. Sorry. But this is virtual. Okay. Let's, any other questions before we get started on where we left off last time? Okay. As some of the questions have indicated, we are in Chapter 1, Functions in the Graphs, and 1.6, a library of parent functions, and we're on cubic square root, page 62, cubic, square roots, and reciprocal functions. We did the cubic function last time. We're now on the square root function, just about the middle of page 62. Okay, now if you think about a square root function, here's the function. F of x equals square root of x. Bells and whistles should go off in your head, okay? Because square roots are one of the places you really have to be careful. Two places that we've talked about. Anytime you have a variable in the denominator, you have to check and make sure no values for that variable will make that denominator 0. If they do, you have to exclude those from the domain, right? So you can't have a denominator being 0. The other thing you can't have is what's inside a radical, especially a square root. You can't have that being negative. You can never take the square root of a negative number, not in the real number system. So that excludes half of the numbers, okay? Anything less than 0, x can't go in there. So as soon as you see a square root function, this thing in here, whatever's under the radical, has to be greater than or equal to 0. Whatever's under the radical. In this case, it's just x. So x has to be greater than or equal to 0. Anything from 0 to the right. Okay? Exclude anything left of 0. Okay? So therefore, the graph of your function will not pass, this one will not pass the y-axis. It's always going to be on the right-hand side. So therefore, the domain of the function is the set of all non-negative real numbers. You can have 0, which is neither positive or negative, and anything positive, but any negative have to be put out. So that's why they phrase it this way, the set of all non-negative real numbers. Now, is there a question? Okay. Here is the other issue here. When you see a square root sign, if it's a naked square root sign, nothing in front of it, that always means the principal square root, the positive square root. In order to get a negative square root, not negative inside, negative on the outside, you have to... Okay, I don't think you're talking to me, are you? Okay, all right. No problem. I hope I wasn't grinding that badly. Okay, all right. All right. Okay. When you see a square root sign, if it doesn't have a minus in front of it, that means it's got to be positive. Okay? That's in front of it. We've already said what's inside can't be negative. What's outside, if there's no minus in front, that means you're dealing with positives. So therefore, written this way, your f, your y values, the range, is also non-negative real numbers. Okay? Non-negative real numbers. Okay? Now, the intercept, when x equals 0, square root of 0 is 0. So is your y. So the intercept is 0, 0. The only one you've got. So many of our functions have had that, okay? Now, how about the increasing nature of the function? If you increase the x, you increase f of x. Oh, here comes Chance back in. I already had him once. He must be having problems, okay? But he's here. I've got him here, hopefully. Let me just make sure nobody else is waiting. Wow, it looks like we lost some people too, so it must be unstable internet. It is rainy and overcast today, and every now and then it gets windy. That may be affecting signals as well. Okay, so what I was saying before, if you increase the x, okay, you're also going to increase the y, the f of x, okay, because the square root of a small number is small, square root of a larger number is larger. So therefore, it's an increasing function, okay, and it's increasing all over its domain, which is from 0 to infinity. Now, one interesting thing here, if you were writing, and I'm going to get the thing to do it, if you were writing the domain here in interval notation, you would have said 0 to infinity. And you have to know it's talking about the domain. If you're writing the range, and oh, here comes Janae back in. She must be having trouble staying in. She was on Google before. That must have messed up with her. I don't know. I don't understand all this mess. Okay. This, you understand, this is also 0 to infinity. But these are not the same things. Oh, you let me get away with that? This is not a bracket. That's in parentheses. You never put an infinity, positive or negative, inside a bracket. It's always a parentheses, like I did here. I was talking and not paying attention. These are your x's. These are the y's. So therefore, this is another reason I don't really care that much for interval notation, because you can't tell what you're looking at. If you write it in set notation, it's a little more to write, but it's not bad. The set of all x's such that x is greater than or equal to 0. That's set notation. This one, even though it's the same interval, it's the set of all y's such that y is greater than or equal to 0. So now you know where that interval is going. Okay. Now, notice down here, this is what I was saying. When they're talking about increasing, decreasing constant, they always put parentheses on both ends. You don't have to have a bracket. Even though the 0 was there, we usually only put the open interval. Okay, if that was 0 to 7, you would have parentheses. Okay, even though up here it may be brackets, down here you would say parentheses. It's not a big deal. I don't count off if you don't do that, but notice in the book they do it. Okay, any questions on this slide? Okay, is someone talking to me, or is that something in the background on someone's phone? Okay, yeah, okay, all right. So let me move on to the next slide. Here is a figure of the square root function. Okay, starts at 0, 0, y-intercept. The domain is only the positive values x. The range is only the positive values for y. Now notice this goes up really sharply here, but then flattens off, never flattens out completely, always increasing, but just increasing at a slower and slower rate. It's increasing really rapidly here, but very slowly out here, but always increasing. So there you see the graph of your square root function. And that's one of your, what they're called the parent functions. Notice there's no negatives on the x and no negatives on the y either. Okay. Any questions on square root function? Okay. Let's move on to reciprocal functions. Now, okay, I hope that's in the background. Yeah, there's several people without a phone muted. Okay, Ladarius just muted his. That may have been who it was. Thank you. Okay. only it's now Lee-Darius. No, I'm just kidding. All right, here is a reciprocal function, 1 over x. Here is the other place that we have to be careful. You have a variable in the denominator. That variable, or that denominator, can't be 0. And since the variable is all that's down there, that means x can't be 0. So what is the domain of this function? Well, if you write it in interval notation like they did, then you have to say everything to the left of 0, that's from negative infinity up to 0, but not counting 0, because 0 can't be counted there. And then you jump over 0, that's not very far to jump. I could even do that maybe. And then from 0 to positive infinity, but not counting 0 either. So this is how you express that in interval notation. Set notation to me is so much easier. Here's what I was doing in set notation, if I can get my pen to show up. Where are you, pen? I can't find, oh, there it is. Okay, down there. Okay. It's the set of all x's such that x is not equal to 0. That's it. Everything else, and this says the same thing, x is not 0, you have to exclude 0 here. Now, what is the range of this function? What values can f take on, y take on? Well, that is, here's the key. The only way y could be 0 if that denominator was ever 0. Because if you have a fractional form, the only way that fraction will be 0 if the numerator is 0. So you can look at this and say, well, no, it can't be 0. Can it be anything else? When x is very large, f is very, very small. Okay? But when x is very, very small, f is very, very large because they're reciprocals of each other. So there, yes, it can take on any value except 0. So therefore, its range is the same thing. And if you didn't know what they were talking about, so if you're setting set notation, that would be set of all y's such that y is not equal to 0. Says the same thing, but it's a lot clearer what it is. You're talking about the x's here, the y's here. Looking at this, you have to read what in the world you're talking about. Now this function is odd. Oh, let's go back to this one. What is that function? Even, odd, or? What's the other option? Neither. There's a neither function. There is no going on the left hand side. So you can't do f of a minus x. It's not defined. So this is a neither function. They didn't mention that. They usually will skip the neithers, but that's a neither. This is an odd function, and we'll show that in just a minute. Why? Well, you can do it. Let's use our test. F of negative x, that's our test for even or odd, and that would be 1 over, plug in a negative x. Well, that's actually negative 1 over x, which is exactly minus f of x. So yeah, that is a negative function. As soon as you see it's the opposite of this one, you don't have to put that last line in, but the book usually does. That's an odd function. Okay, and we'll see what that looks like. The graph has no intercepts because x can't be 0, so there can't be a y-intercept. Y can't be 0, there's no x-intercept. No intercepts. Okay? Now, this function actually is decreasing everywhere it's defined, from negative infinity to 0, and also from 0 to positive infinity. Okay? So it's decreasing everywhere. The graph is symmetric with respect to the origin. That's saying the same thing as the fact that the function is odd. These two statements are the same. Okay? These two statements together tell you that it has no intercepts. So the sum of these two is the same as that one, because it has no, it doesn't, x is never 0, y is never 0, so it has no intercepts. Okay, so I think we're ready to look at the here it is. For positive x's, if they're very small positive x's, that's going to positive infinity. Okay, never reaches x equals 0. Never, because you can't divide by 0. But for big X's, it's going to 0, because 1 over a huge number is really, really, really close to 0. Okay? But if you go on the negative side, 1 over a negative really large number is going to be approaching 0 again, and 1 over a negative very small number, getting closer and closer to 0, is getting incredibly large negative. And you see these do reflect across the origin. That's an odd function. F of x, f of minus x is the opposite of f of a. F of minus x is this value, f of x is that value. Exactly opposite across the origin. Does that make sense? There's your reciprocal functions. Okay. The next type we deal with is step and piecewise defined functions. Okay. Now, what in the world do we mean by that? Well, these are two different things, but step functions are always piecewise defined, but there are other piecewise defined functions that aren't step functions. So let's see what they're talking about. Functions whose graphs resemble a set of stair steps. Okay, those are called step functions. And they say the most famous of these, I don't know why they're so famous, I never use them much, the greatest integer function. But all math books love to talk about them, and this is about the only place they do is using this as an example here. I don't know of many people that use the greatest integer function. I'm sure someone does. Here's how you denote it. It's inside, whatever's inside the double bracket, it's the greatest integer of this thing that's less than or equal to that thing. Okay, so here's what we're saying. F of x, if its greatest integer in x, okay, is the greatest integer less than or equal to x. So give me a number. Make up a number, any number in the world. Give me a number. 25. The greatest integer less than or equal to 25 is, of course, 25, because 25 is an integer and it's equal to 25. So give me another number that is not an integer. Anybody? Not that hard. Give me a number that's not an integer. Say again? I can't hear you. You're coming in very weak. Say again? Okay, 5 is also an integer, but the greatest integer in 5 is 5, because that's equal to 5. Give me a number not an integer. Say again? Okay, how about negative 5? That's also an integer, and the greatest integer less than or equal to negative 5 is negative 5. Okay, I'm glad you went negative there. Okay, not in the bad sense. Give me a number not an integer. You're going to start kicking yourselves in a minute when I tell you one. 9. Okay, both of those are integers, but the greatest integer in 9 is 9, because it's equal to 9. Greatest integer in 0 is 0, because 0 is equal to 0. Say again? 1. Greatest integer in 1, and 1's an integer. 2. All those are integers. 3/4. Excellent, excellent, excellent. Okay. 3/4 is not an integer. What's the greatest integer less than or equal to 3/4? 1's greater than 3/4. Otherwise, I'll give you 75 cents, you give me $1, and we'll be even, okay? No, okay, I'm just kidding. Okay, 0 would be the greatest integer less than or equal to 3/4. You're absolutely right. Now, one way to think of this, and this is, you might say, is a really bizarre way to think of it, think of your number line here, okay? That should be a line. It's a pretty wiggly one. And that would be 0, 1, 2, 3, 4, 5, 6. Negative 1. So I'm glad someone went negative on me, even if they gave me an integer. Negative 2, negative 3, negative 4, blah, blah, blah. 3/4 was right here, right? Somewhere right around in there. Greatest integer less than or equal to 3/4, you look to the left to find the next integer. That was 0. Now, what if you had said -3/4? So it was here. What would be the greatest integer in -3/4? -1. You go the other way. So on the positive end, if you had a number like 1 3/4, or let's do 3 3/4, you just lose the 3/4, because this would be 1, 2, 3, and 3/4 would be here. Go to the left and there. If you had -3 3/4, that would be 1, 2, 3, and 3/4 here. You have to go the other way. You can't just drop the fraction. That would be a -4. Does that make sense? Same thing with decimals. If this was 3.75, if it's on the positive side, just get rid of the decimal, and this would be 3. That's the same number. If it was -3.75, you can't just, whoa, here comes Shay. Back, let's see, I don't know if she was here yet or not. Was Shay here yet? I think so. Wait, let me see. Yeah, I think I already had Shay here. I thought so. Okay, so I like to picture it on the number line. Even though I don't draw it, I think of it that way. Okay, so that's what we mean. The greatest integer less than or equal to whatever is in the bracket, or whatever you call that symbol. So -1, because that is an integer, that would be -1. -1/2, however, that would be right there next to -1/4. That would also be -1. The greatest integer less than or equal to -1/2. To the left of -1/2 on the number line, that would be -1. Does everybody see that? Okay. Now, what are some characteristics of this graph? I can't get it to advance until I click on the slide. Okay, here we go. Oh, here's some more. The greatest integer in 1/10, what would that be? 0. 1.5, what would that be? 1. 1.9? 1 also. 2.1, that would be 2. -1.9 would have been -2. Perfect, y'all got it. The graph of the greatest integer function looks like this. They went to the graph first, not the other things first. It's a stepwise function. You can almost picture walking up the steps here, right? That's a stepwise defined function. I can't walk with my fingers too well. It's not the yellow pages. Now, notice some other features of it. On the end, you have a closed circle. A closed dot. On the right hand end, the left hand end is a closed dot, right hand end is an open dot, because the greatest integer in -3 is no longer -4, but -3. And so on like that. That's why you step up at the open to go up to this one. Now, for positives, same thing. Anything between 0 and 1, the greatest integer would be 0, including 0, but when you get to 1, it steps up and becomes that one. So that's why it's a step function, going up. Now, what's the domain of the greatest integer function? All real numbers. Any real number you want to put down there. -pi3 would be an irrational number, but that's something, and let's see, pi3 is something just a little bit less than -1. Greatest integer in that would be -2. Okay, so any domain, any real number you can put in there. What's the range, however? The range is not all real numbers, but it's all integers, because the range is only -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, negative. So there we have it. It's just all integers. nothing but integers because it's the greatest integer in that number. So we jumped ahead to that. Now, that's not easy to put in set notation. That's not easy to put in interval notation. In fact, almost impossible. So you basically have to just write out the name. Set of all real numbers would be. Set of all integers, that would be really hard to do. The range of the function is set of all integers. Now, how about y-intercepts? To be a function, there can only be one. If you look back at it, the only place this crosses the y-axis is at 0. So 0, 0 is the y-intercept, okay? But the x-intercept is every point between 0 and 1, including 0, but not including 1. So that in interval notation would be close bracket 0 up to parentheses 1. So the y-intercept is a single point. You have an infinite number of x-intercepts, any number between 0 and 1, counting 0 but not counting 1. Okay, because that's where they cross the x-axis or touch the x-axis. The graph is constant between each consecutive pair of integers, but is neither. Then it increases there, but it jumps vertically 1 unit at each integer. But that's not called an increasing function. It's constant between the integers and then jumps up 1. So it does increase only at the integral values. And then it's a jump. It's not a gradual increase, it's a jump. We'll talk about that later if you ever get into calculus. Jump discontinuities. Okay. All right. Jumps vertically 1 unit each integer. They've already done the graph. So here's example 2. Evaluate this function when x is -1, positive 2, and 3/2. So what is f at -1? Well, that would be the greatest integer in -1. Put the everywhere you see an x here, put an x there. So where you see an x up here, put a -1 here, plus 1. And what is the greatest integer in -1? Anybody? Help me. I'm here all by myself. You're letting me sink here. Greatest integer in -1 is -1. And -1 plus 1 is, no, it's 0. Yeah, okay, good deal. Okay, what is f of 2? F of 2 is the greatest integer in 2 plus 1, because f adds 1 to that. So what's the greatest integer in 2? 2 plus 1 is 3. Excellent. So what's the f of 3/2? Where f is the greatest integer in 3/2 plus 1. What's the greatest integer in 3/2? No, it's not an integer. Greatest integer in 3/2 is, okay, 1. 1 plus 1 is 2. Didn't know you'd be doing such high-level math today. It sort of dawns on me that maybe I needed to review our nomenclature here. Let's go back to preschool, wherever, when you first learned to count. When you counted, you used the numbers 1, 2, 3, 4, 5, 6, 7. Now, that has a name in mathematics. It actually has 2 names. It's called the counting numbers. That makes sense. It's also called the natural numbers. Okay, so if you hear in math they talk about the set of counting numbers or natural numbers, that's just the numbers we use to count with. 1, 2, 3, 4, 5, 6, 7. Okay, now just to get the names in place, anytime if you negated those numbers, and you didn't do this back in preschool, Okay, but at some point or another you learn to negate numbers, and if you included all the integers and the negative of those, I mean all the counting numbers, oh wait, let me throw this one in. The next set of numbers was adding not much, 0. Add 0 to the counting numbers, and that gives you the set we call the whole numbers. Whole numbers include 0. The counting numbers and natural numbers don't include zeros. They're just 1, 2, 3, 4, 5. Include 0, you get the set of whole numbers. Now take the counting numbers, the whole numbers, and negate them, but keep the others. That now is a set of integers. It's the counting numbers, 1, 2, 3, 4, 5, and all their negatives. That's what we mean by integers. Now, if you were to look at the number 3/2, which I'm trying to move my cursor on the Wacom, the number 3/2, that we would call a fraction. But that's not what the technical name is. That's called a rational number because it's a ratio of 3 to 2. A fraction, yes, but it's also a rational number. So a rational number is a set of all numbers that can be expressed as the ratio of two integers as long as the one on the bottom is not 0. So it's a ratio of all integers to basically counting numbers. Okay, that excludes, or natural numbers, it excludes 0 in the denominator. So that's what are called the rational numbers. Now the irrational numbers are those numbers that can't be expressed as a ratio. And here's the other thing about rational numbers. Like 3/2, you could also express that as 1.5. That is called a terminating decimal because it stops after the first digit. However, if that would have been 2/3, then that decimal would be 0.6666666, and it goes on and on and on, repeating the sixes forever. So a rational number can either be expressed as a terminating decimal, one that ends at some point out there, or one that repeats itself. What an irrational number is one that doesn't repeat itself. Now I'm going to pull out my handy dandy calculator here, and do any of you happen to know an irrational number? If you don't, I'll tell you one, but do any of you happen to know one? Okay, I'm going to have to turn my calculator sideways to get it. It's my phone. Okay, does anyone know an irrational number? You all do, you just don't realize it. Let's take that 2 that we have there and do, where is my pen? There it is. Let's do the square root of 2. So I'm going to do the square root of 2 on my calculator, on my phone. I have to press the 2 first, and then, it didn't press, did it? Let me do it again. Oh yeah, my fat fingers, little keys. Okay, here's the square root key. I don't know if you can see it right there. Okay, so I'm going to press the square root key, and here's what I get. Okay, now there's no guarantee just looking at this, but it sure gives you the suggestion that there is no repeating elements going on there at all. It starts off like it would be 1.414, but then it botches up. 2, 1, 3, 5, 6, 2, 3, 7, 3, 0, 9, 5, blah, 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 blah. It goes on forever without repeating any pattern whatsoever. That's an irrational number. Other irrational numbers that you might be familiar with, and I can't find, there's my pen. Pi is an irrational number. Let me do pi on the calculator. There is a little pi key down here, right down there, so I'm going to press pi, and there it is, 3.141592653589793, blah, 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 blah. It goes on and on and on, never repeating any pattern whatsoever. Those are the irrational numbers. square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, pi. There's another number we haven't hit yet. Hopefully before the end of the course we'll get there. It's the number e. And that's on your calculator as well. You'll see e to the x. I don't know if you can read that somewhere right there. So what I'm going to do is press a 1. Can't get it to press. Let me clear this. Okay. 1. And then I'm going to press the E key if I can find it now. There it is. Press the E key and there's that number. 2.718281828. Oh, it looks like it's got repeating. No, it doesn't. 459045. It never repeats. It acts like it's going to. It doesn't. That's an irrational number as well. There's tons of irrational numbers out there. Now, okay, you'll think, goodness, why has he off onto that? Well, it's because it sort of came up. So counting numbers or natural numbers are only the ones we count with. 1, 2, 3, 4, 5. Include 0, you get whole numbers. Do the opposites, the negatives of the counting numbers with 0, you get the integers. Ratios of integers are rational numbers. And by the way, all integers are rational numbers. For instance, 3. 3 can be written as, if I can get my pen, 3 over 1. That's a ratio of 2 integers. So that's a perfectly good rational numbers. So all integers are rational numbers, but not all rational numbers are integers. Okay? Now, when you combine the rational numbers with these irrational numbers, that's what gives you the set of real numbers. So when we say all real numbers, we mean every one of them. Those that can be expressed as ratios and those that cannot. All real numbers. Okay? So, I was sort of getting the idea y'all weren't quite clear on what integers were as opposed to other numbers. So there we have it. Sorry, that probably took too much time. So we've done it. We got 0, 3, and 2. Let's see what they get. For the greatest integer for x equal -1, the greatest integer less than or equal to -1 is -1. So the f of -1 would be the greatest integer in -1 plus 1, which would be -1 plus 1 equals 0. And that's what we got here. Okay? And then for x equal 2, the greatest integer less than or equal to 2 is 2. So f of 2, which is greatest integer in 2, plus 1 would be 2 plus 1, which is 3, which is what we got. And for the x equal 3/2, the greatest integer less than or equal to 3/2 is 1 again, is 1. So f of 3/2 would be the greatest integer in 3/2 plus 1, and that would be 1 plus 1 is 2. Now, if you were to graph this one, I think they do. Yeah, here it is. Notice how similar that looks to the first greatest integer function. The only difference is this thing right here was down here then. This one was down there. This one was down here. This one was down there. This one was down here. This one was down here. This was down there. Everything dropped. Well, that's what you did. You took the greatest integer function and added 1 to it. So you stepped up by 1 on the y's, or the f of x was 1 more than what this was. So sure enough, it's still a step function. You just moved the steps over one place. Okay, moved them up one place. We'll be talking about that in the next section. That's called a translation. We'll talk about that later. Now we're talking about, let's see, that was example 2. There's a checkpoint after every example, so please do your checkpoints. Okay, now they skipped the next part, which is a shame. So I'm going to have to, I've got my Wacom here. Let's go to the whiteboard because this is an important concept and they skipped it on the PowerPoint. I'm sorry they did. Now I've got to do some housekeeping here. You can't see it, but I'm moving this toolbar over to the right. I'm going to move Braxton and the rest of you over to the right, and then I'm going to take my whiteboard and move it left as far as I can to get the maximum amount of white space. Oops, I moved it too far.
It's 9:40.
You're kidding me. Okay, we've only got 5 minutes, so let's get this one done. This is important. Okay. Here, and this one, by the way, is also at larsonprecalculus.com. You can look at it. This is another piecewise defined function, which is not a step function. So they left this one out. F of x, and we did talk about these earlier. This is a piecewise defined function, and it's 2x plus 3 for any values of x less than or equal to 1, and it is minus x plus 4 for any values of x greater than 1. Okay, now I wish I had a graph board. My old thing I used to use was called, okay, Tyler must have had to leave. He's come back. I'm pretty sure I had him here already. Yep, had him here. Okay, now, we got 4 minutes. I'm going to try to draw my XY axis here. Okay, now let's start, maybe do a t-table. Do y'all like t-tables? Let's do x here, y here, and let's do our calculations. And I'm going to give it to you. Give me an x. 2. Okay. And where in the world is 2, Waldo? Is it in this part of the domain or in that part of the domain? The top part or the bottom part? In the bottom part. So we'll take negative 2 plus 4 would be 2. Okay. Give me another x. Oh, let's go on and plot it while we're here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 3, 4, 5, 6, 6. So I won't need all these while I'm putting them in here. Okay. So 2, 2 would be right 2, up 2. Okay, we got it right there somewhere. Okay. Give me another x. 4. Okay. Going for the biggies today. What would 4 be? In the upper group or the bottom group? Bottom again. So minus 4 plus 4 would be 0. So when x is 4, y is 0. Right there we are. Okay. Give me another x. Negative 2. Good choice. Okay. Where are we, Waldo? Upper part or lower part? Upper part. So when you put a negative 2 in here, you get 2 times negative 2 is negative 4 plus 3 would be a negative 1. Okay. So negative 2 gets you down here to negative 1. So there you are, somewhere right in there. Okay. Now, since we're running out of time, I'm going to pause for a moment here. The key here is that 1, x equal 1. So let's go on and pick that one up. And which function, which one part of the function would you be? The top part or the bottom part? Bottom part. No, you wouldn't. This is x is less than or equal to 1. So you would be in the top part. Okay, so it'd be 2 times 1 is 2 plus 3 is 5. So this would be 5. So 1, 1, 2, 3, 4, 5. I'm glad I went that high. Okay, somewhere right about there. Okay, and that's the end. So I'm going to make that sort of a big dot there. Okay, now I think you can see to the right of that, you're going downhill, right? Through all those points. And sure enough, oh, that's not right. I'm sorry, I went the wrong way. Sorry. I was going to say, this is not right at all. We were on the top part of this. That's not here. Okay? That is here. And we didn't have enough points here, but sure enough, they do something like this. That's what we're doing. Okay? And we include that point there. Okay? Because our slope is 2, our y-intercept is 3. I should be right through that point there. I missed it a little bit. But you see, that's that line. Slope of 2, y-intercept of positive 3. So I should have put that one in. Now this one doesn't go quite to 1. It goes right up to it, but not quite. What would happen if we put a 1 in this one? That would be a minus 1 plus 4 would be a minus 3. No, minus 1 plus 4 would be a plus 3. That would be right here. But we don't go there, so I'm going to put a circle there. Meaning you get right up to that circle, but not quite. And then from here, you go downhill through these points. I missed that one, but it goes down like this. Well, sure enough, that has a slope of minus 1. And if you had gone over to 0, it would have intersected at plus 4. But it doesn't go there because it stops. So this is your graph of your piecewise defined function. You can't put all the points in, but get a few, especially the one where things change. Put it a solid dot there where the equal sign is, and put an open circle there where there's no equal sign. And then do enough other points so you know where it's going from there. Does that make sense? All right. I know we just went over. Sorry about that. But you know what? No extra charge today. Okay. So we finished example 3. Checkpoint always in the book. We will start next time with the parent functions. We did not quite finish 1.6. Homework exercises here would be either 11 or 13, both at Calc Chat. 11 is at Calc View. Any of the odds 15 to 25, all at Calc Chat. 27 or 29, both at Calc Chat. 27 is at Calc View. 31 or 33, both at Calc Chat. 31 is at Calc View. Any of the odds 35 to 39, all at Calc Chat. 35 is at Calc View. 41's at Calc Chat. 43, let's say any of the odds, either 43 or 40, no, any of the odds 43 to 47, they're all at Calc Chat. True false 49, and that's it. So now I've got a question for you guys. We didn't quite finish the parent function, so we're not quite through with everything for the test. Do you want me to go on and post the test out there so you can get started on it? If you run into a parent function question, which I don't think you will, you can just wait until we talk about that next time. But you can go on and get started on the test. Do you want me to do that? Or do you want to wait until Tuesday and get the test? Anybody? Give me an answer. Well, you can always wait to do it, but you want it available to you so if you have a chance, you can start on it this weekend. Okay, I will post it. I'll try to post it in both of those places I said. For people who came in late, you'll have to go back and listen to the YouTube videos. Now, I don't know where the guy was who was complaining that he couldn't get in the Zoom last time. We have what? We probably lost some people now. We had like 20 or 21 students here. I don't know why he's not able to get in, but you know, we were here. The Zoom worked, the invite worked, everything worked. So anyway,
How many attempts will we have on our test, Mr. Fowler?
it's an open book, open notes test. Get it done. Yeah. So I mean, go for it. You know. Yeah. And now this used to be a quiz. Used to be a take-home quiz before when we were on campus, and then the test would come at the end of the chapter, and that would be in class. We don't have any in class anymore, so I just made all the quizzes tests and all the tests. Okay, so this is now your test 1. It will say Q1 on the thing because it used to be a quiz. Don't sweat that. Now, you will need graph paper. Do y'all need me to put a piece of graph paper out there on with the test? Or do y'all all have graph paper? Okay. Okay, but if anyone needs it, I'll put it out there. I thought I heard a yes. So did someone say yes? Any one person say yes? I'll put it out there. Okay. Okay. I'll put it out there. That would be easy to do. I have to do a what you call it, scan of it and do the test. I can't remember if it's going to be as a PDF file or if it's going to be a Word file. I think it may be PDF, and the graph paper will also be PDF. So they may not be perfect because I'm not really good at that, but I don't have a scanning machine. I just have to use an iPad to do it. So I'll try to get it there for you, and I'll do it sometime late this evening. I don't have any time before or late this evening. I'll try to put it out there. So any last thoughts, questions, anything? Yeah. All righty. I don't feel like I'm doing much, but trying the best I can. Tough situation, and I want you to learn math. So I'm trying to do whatever I can do to help you learn math. So that's my job. Thank you. You do too. Thank you. I'm going to stop sharing now, and unless there's any last thoughts or shots, I'm going to end the meeting for everybody. Bye-bye, folks. Have a good, safe weekend. Be safe. Be careful. If it's raining, do a lot of math. That'll make you feel good. Bye-bye.